Hello again. Before we move on, let's take a look at these three problems here. In these problems, what we asked to do is to determine the units of the constant of proportionality of these principles. Newton's law of gravitation, or Newton's law of universal gravitation, which states that every particle with mass in the universe gets another particle with a force that is directly proportional to the product of their masses, and force is inversely proportional to the square of the distance between their centers. Okay, and then the second one is Coulomb's law, which has the same mathematical format as Newton's law of gravitation. Coulomb's law states that the electrostatic force between two stationary point charges is directly proportional to the product of the magnitude of the charges and is inversely proportional to the square of the distance between them. Right. And then the third one is the Planck-Einstein relation, which you've seen, or you will see when you're doing the photoelectric effect, grade 12. The principle states that the energy of a photon is directly proportional to its frequency. Okay. Now, how do we do these problems? Can you figure out how to answer these questions? You can pause the video and try them by yourself, and then come back and view my solutions. All right. So the first step is to write the principle in the mathematical form of this law. So number one, we will first let the masses be m1, m2, okay, and r be the distance between their centers. B distance between their centers. Okay. Okay. So then it says that the force is directly proportional to the product of their masses. So that is to say, F is directly proportional, that's a symbol for proportionality, to the product. So we'll multiply M1 and M2, right? And that this force is inversely proportional, so that's 1 over the square of the distance between their centers. So that's how we write it. And then this leads us to F being directly proportional to M1, M2 divided by what? By R squared. So that is direct proportional product of the masses and the inverse proportionality with the square of the distance being the denominator. And then we will convert this to an equation. So we'll remove this proportionality sign or replace it with an equal sign. Now, when we do that, we will have to introduce the constant of proportionality. So that's how we do these problems. In this case, the constant of proportionality you may already know. It's called G. It is the symbol G, rather. So we'll say that F, the symbol G, for the gravitational constant, and then this is M1, M2 over square of R. Now the question, we want to determine the units of G, basically. Okay. Now the maths way of doing it would be to solve for G being FR squared over M1, M2, and then you substitute the units of the right hand side. So the units of G, the right hand side has the units newtons, and this one is meter squared divided by kg times kg is kilogram squared, So that's equal to Newton meter squared kg to the minus 2, sorry, so per square kilogram. Okay, let me fix this as kg minus 2. All right, we can, if you wish, go further and write this in terms of base units only. Now, in terms of base units or fundamental units, kg is already a fundamental unit and meters is already a fundamental. So all you will do is to replace newtons in terms of the fundamental units. So then you will write Newton, let's do that here. So Newton meter squared per square kilogram, yes, and then write Newton as kilograms meters per square second, and then you write the meter squared here and the kilograms to the minus 2 there. Right, so this implies that Newton meter squared per square kilograms, okay, which is the units of G in terms of base units. I'll just start with probably meter here, meter cubed, and then I'll do the kilograms per kilogram. That's 1 plus minus 2. This one is 1 plus 2, that's 3, and then I have the square circle there. Okay. And then we do this one as well. The second one is Coulomb's law, which also takes the same form. So Coulomb's law, but in Coulomb's law I'll do something a bit different. I'll first write it because it's pretty much the same as number 1. So I'll simply write F being proportional to the product of the charges. I'll let the charges be Q1 and Q2, and then the distance out there, and then I'll say that the force is the Coulomb's constant K Q1 Q2 over R squared. Now I'll do an argument to determine the units of K here. So I'll determine the units of K as follows. All right, so when we look at this equation, on the left hand side we have the units are Newton. We have newtons here. So then the equality sign says that if I have newtons on the left hand side, then I will have to have newtons also on the what? On the right hand side. That's dimensional analysis. Okay, so I need newtons on the right hand side, and this units is Coulomb, this is Coulomb, and then this is R squared. So there's no way you can get newtons here. So then you will have to put in so K has to have newtons in order to have newtons there. Okay. now that K has newtons, at least on the left hand side we have Newton, then on the right hand side we also have newtons. Okay, now but the right hand side has this Coulomb times Coulomb, so then we only need newtons on the right hand side, not Coulomb squared. So we will introduce Coulomb to the minus 2 to cancel out this Coulomb squared there. What about this meter squared on the denominator? We need to get rid of that as well, so that K is only so that when you multiply the units of K by this, then you are only left with newtons. So the units of K must contain newtons and the Coulomb to the minus 2 to cancel out this Coulomb squared, and also to cancel out this meter squared here. So since the meter squared is in the denominator, so we put meter squared here in the numerator. Okay, so these are the units of the constant of proportional for Coulomb's constant. Okay, which is that's what you will see. It's, let me just write Newton meter squared, Coulomb squared that way. Okay. And then part 3 should be trivial if you're following that. So part 3 says that the energy is directly proportional to the frequency. Okay. Now, the constant of proportionality here is a symbol H, which is a Planck's constant. So then E is equal to HF. And again, it's really up to you how you want to determine the units of this constant of proportionality, whether to mathematically do so or to argue that the units of the left hand side is joules. So also the right hand side you need joules. Okay, so the units of H must contain what? Joules. All right, but then you have this units of frequency, which is hertz. Hertz is per second. Okay, so how do you cancel it per second? You just cancel it with what? With second. So these are the units of Planck's constant, which is joules times second. If you're not convinced, you can mathematically solve for H and then substitute in the units there, joules. The units of frequency, it's hertz, which is per second, and that gives you joules second again. And right, and in terms of base units, joule second is equal to you just write the units of I can't remember what the base units for joules, but I know that they are units of energy in terms of force times distance. So that's where I start. Newtons meters second, and then I go on and replace the newtons with the kilograms meters per square second times meters second, right? And then that is that joules second is equal to kilograms meter squared per square second. Okay, so these will be the units of the Planck's constant. Oh, sorry, I think that's 7 minus 2, 7 that should be per second. Should be second to the minus 1 there. Okay, so that is a second. All right, so that is that's it for this activity. I think now we will move on to look at scales and scientific prefix. You can, if you want, practice. The purpose of this activity is that you familiarize yourself with the SI units, and grade 12s will know that some of the content here in these videos may appear in multiple choice. I don't know, but it may. All right, so anyway, if you wish, you can do these activities for yourself, and then you can come back and ask me for answers, or maybe just Google the answers. I don't know, it's up to you. All right, thank you. Bye. Bye.